In this video we're going to use Django and HTMX along with WebSockets to build an application that allows the server to push notifications to front-end clients. We're going to see how to set up Django channels in this video in order to deal with WebSocket connections, and we're going to see how we can use HTMX's WebSocket extension to connect to the server. We'll then see how to use Django and Django channels to push WebSocket messages to the clients. Finally, we're going to see how the HTMX WebSocket extension handles the messages from the server and puts content into the DOM, and we'll see other client-side tasks such as clearing the notifications as well. So let's get started. So for this video we have a GitHub repository here which I'll link below the video. On the master branch we have the starter code, and there's also a final branch here that contains the final code at the end of the video. So what you should do to get started is clone this master branch, and then we can go to VS Code where I've already got that cloned, and we can run the python manage.py migrate command, and that will generate a database. Once you've generated your database, what we're going to do is we're going to run the development server here, and we're going to have a look at the application from the starter code. Now, as you can see in requirements.txt, we have this package called Django All-Auth installed, and this package basically provides you out of the box with registration, login and logout functionality. We're going to use that in this video because the goal of the application is going to be when we sign up for the application, it's going to send notifications to all existing users. So let's go to our page here, and you can see we have a very basic page. It contains this message here, and there's a sign up and login link at the top, and these are Django All-Auth forms. They're very basic. You can style them up if you want to, but we're not going to do that in this video. At the top right you can see we have a notification bell. At the moment we have no notifications, but later in the video what we hope to do is when a new user signs up and we're on this page, without refreshing or without doing anything, we're going to be getting a notification because the Django server is going to push that WebSocket data to the client, and when it does, we hope to see that notification at the top right. So let's get started with the video. The first thing that we're going to do is go to Django Channels documentation. The installation section gives you this command to run to install Django Channels along with the 𝗬𝗚𝗡 server 𝗬𝗏𝗡. I'm going to make the text a little bit larger here. So what we're going to do once you've installed those, we're going to add 𝗬𝗏𝗡 and channels to installed apps. So let's go to our project. I've already installed these. We're going to go to settings.py, and if we scroll down to installed apps, at the top of these installed apps we're going to add the 𝗬𝗏𝗡 𝗬𝗏𝗡 server, and if we go down to the bottom just underneath the all-auth applications, we're going to add channels to the installed apps. Now if we save settings.py, you can see at the bottom we get a command error, and that's because we haven't set the 𝗬𝗏𝗡 application setting. Because we are using an asynchronous 𝗬𝗏𝗡 server, we need to set this and point it to the application object. So if we scroll down to the bottom of this settings file, we're going to add that 𝗬𝗏𝗡 application setting, and we're going to point it to our 𝗬𝗏𝗡.py file. You can see that on the left hand side. It's under the project folder which is called HTMX_WebSockets. So what we're going to do is we're going to go to the project folder HTMX WebSockets. We are going to the 𝗬𝗏𝗡 file, and it's going to be the application object. So this setting just tells Django where the 𝗬𝗏𝗡 application object lives. What we're now going to do is actually go to that file, and we're going to change the settings here in this file. And to do that, again, we're going to reference the documentation. So let's go back to Django channels, and you can see that in the 𝗬𝗏𝗡.py file, what we're going to do is define this protocol type router. So let's grab the import, and we're going to copy that into 𝗬𝗏𝗡.py at the top. So from channels.routing, we've imported the protocol type router. And then underneath the application object, what we're going to do is instantiate the protocol type router. Let's copy this code from the documentation, and we're going to paste that down here, and we can change the name of the application that's being referred to application. So let's go through this file very quickly. We are setting the Django settings module on line 5 here. Underneath that we instantiate the 𝗬𝗏𝗡 application, and then on line 9 we instantiate a protocol type router, and we're setting a key within that dictionary to HTTP and pointing that to our application here. Now HTTP is the default protocol for Django applications. What we're going to do a bit later on in this video is add another key called WebSocket, and that key is going to determine how WebSocket connections are handled when they arrive at the server. But for now we're just going to leave it at HTTP, but that's why this is called a protocol type router. It takes the protocol and it determines what happens when a connection with that protocol is received. So let's save the 𝗬𝗏𝗡.py file, and we're going to restart the Django development server. Now once that starts running, you can see at the bottom it's started an 𝗬𝗚ci/𝗵𝗽 server. So when you run the run server command and you have an 𝗬𝗚ci application, 𝗵𝗽 takes control of the server and it allows asynchronous operations to be performed, and we're going to need that when we use Django Channels in this video. So we're now going to move on to HTMX's WebSocket client. We're going to install that and use that in our application. But before we do that, let's once again go over the goal of this video. If we go back to the application, when a user signs up to the application, we want Django to push a WebSocket message out to all clients, and then that will show as a notification at the top right here. So what we're going to do is use the HTMX WebSocket extension, and that's going to be used to instantiate a connection from the client to our Django server. So let's go to the documentation for this WebSocket extension for HTMX. As you can see at the top, it enables bidirectional communication with WebSocket servers directly from HTML. Now, in order to use this extension, we need to add this script to our base template. So let's go to the templates directory and go to our base template. And you can see we've got a few by default here. We've got HTMX and Tailwind along with Tailwind elements. Just underneath that, we're going to add another one, and that's for the HTMX WebSocket extension. Let's paste that into the base.html's head tag, and then we can go back to the documentation. So if we scroll down a little bit here, we have a div tag, and it's got an hx-ext attribute. We've not seen this one before on this channel, but basically when you're using an extension with HTMX, this is how you can define that extension is being used in your application. And as well as that, we have another attribute here, WSConnect, and that determines the endpoint with which the client will establish a WebSocket connection with the server. So let's copy these two attributes, and we're going to go back to VS Code, and in the base.html, I'm just going to add these to the body tag. So let's paste them in here. Now we're going to change the endpoint here that's being connected to. We're not defining a chat room here. What we're going to do is add another endpoint, and I'm going to paste one in here. It's the /ws/notifications. Now it's considered a good practice with Django Channels if you prefix your WebSocket URLs with this /ws. It can make deploying Channels projects a little bit easier. So once we've added that to the body tag, let's go back to our page, and we're going to refresh this page. And if we go back to Django and look at the terminal, you can see that there's a WebSocket connection. We're trying to connect to Django by WebSocket, but we're getting a disconnect and an error message, and that's because at the moment we do not have an endpoint here for this WebSocket connection. So the next step in this application is that we need to create something at this endpoint that's able to handle the WebSocket connection, and in Django Channels that is called a consumer. So we're going to go to the documentation here, and I'll link this page below the video. We're going to scroll down here, and as it says, we're going to create a new file called consumers.py, and that's going to be within the core application. So let's create that file just now, and within this file we're going to create a subclass of the WebSocket consumer from Django Channels. So we're going to copy this line of code, and we're going to paste it at the top of consumers.py. From channels.generic.websocket we import the WebSocket consumer, and then we can create a class below that, and that class can then handle WebSocket connections from the client, and it can handle sending and receiving messages. So let's create a subclass. It's called the notification consumer, and that will inherit from the WebSocket consumer. And if we go back to the documentation for the consumer, you can see that it has certain methods on that class. Now we need a connect and disconnect method here, so we're going to copy these and paste them into our consumer. And the connect method, as you can imagine, that's what's called when a client first connects to the WebSocket consumer, and that calls the self.accept method in order to accept the WebSocket connection. You can also reject the connection, which we'll see at the end of the video. And we also have a disconnect method that's called when a client disconnects from the consumer, and we're going to add some code here later on as well. Now let's go back to the documentation for this page, and if we scroll down we can see more details here. We can see that this WebSocket consumer class is a synchronous class. Now Channels also supports writing asynchronous consumers for greater performance, but these are a bit more difficult to handle. We could do this in this video, but we're just going to stick with the synchronous version of these consumers. Now if we scroll down just below that section, the next step in this video is we need to create a routing configuration. So what we're going to do is we're going to create this file called routing.py, and again that's going to be within the core application. If we go back to the documentation, what we're going to do is basically define WebSocket URL patterns, very similar to the normal urls.py file, but instead of Django views, these WebSocket WebSocket URLs are going to connect to the consumer classes. So let's go back to our new routing.py file and we're going to paste this code in here. You can see we have WebSocket URL patterns, and this URL here, it matches what we defined in the base.html for the HTMX WebSocket extension. That's trying to connect to /ws/notifications. So we define that URL here in the WebSocket URL patterns, and we are connecting that to our notification consumer, and that's the class that we've just defined here in the consumers.py file. And finally, in the routing.py file, we're calling the 𝗏𝗏 function. That's a static function on a consumer in Django Channels, and that will allow it to handle that connection. And if you've worked with Django class-based views before, this is very similar to the asView function. So let's save the routing.py file and go back to the documentation. If we scroll down, you can see that the next step here is to point the main ASCII configuration at this new routing module. So what we're going to do is take a lot of the code from this file here, and we're going to paste that into the asgi.py file. So let's copy all this code here, and this is defining a bunch of imports from Django Channels. We're going to paste these into the asgi.py file at the top. Now, before we had the protocol type router and the getASCII application, we're now importing the auth middleware stack, the URL router, and the allowed hosts origin validator. So these are quite verbose classes, but we're going to see what some of them are doing in a second. Let's go back to the documentation. The next thing we're going to do is import the routing module. You can see that this is done here. We're going to do that underneath the application object. We're going to import from the core application the routing module. And the final thing we're going to do is we're going to remove this comment from the protocol type router, and we're going to add a new protocol, and that's the WebSocket protocol. So let's add that as a key to this dictionary here, and the value for this we're going to get from the documentation. Let's copy this code here that's defined for the WebSocket key, and we'll paste it in here. And all we need to do here is change the chat application to the core application that we have in our project. And what this is doing is it's taking these WebSocket URL patterns and it's giving them to what's called a URL router in Django Channels, and that's used to expose certain attributes from the URL, like parameters, to the consumer class. And we're also using the auth middleware stack, which adds the user to what's called the scope. We're going to see that later in the video. You don't need to know the finer details of this, you just need to copy the code from the documentation. And once you've done that, you can save the asgi.py file and close it. We're not going to go back to that file in this video. Now let's run the Django development server again and go back to our page, and we're going to refresh this page. And we're going to see if we get a WebSocket connection between the client and our Django server. If we go back to the terminal, you can see that we have the WebSocket handshake and we are actually getting a connection. So now that we're getting the connection, what are we actually going to try and do with our consumer class? Well, when the client initiates a connection with our server, we want to accept that connection. We're already doing that. But what we also want to do is when a user signs up to our application, and they can do that with this form here, what we want to do is we want to broadcast that message as a notification to all users that are on the page, and then those users will receive the data from the WebSocket from the server, and they will then show a message on the front end, and that will be handled by the HTMX WebSocket client. So that's what we're going to try and achieve. Now, one important detail about Django Channels, if we go back to the consumer class, each client that creates a WebSocket connection with the Django Channels consumer will receive their own instance of the consumer. What we need to do is track each of these instances. They're called channels. We need to track them in what's called a group in Django Channels. So what we're going to do is go back to Django Channels documentation here, and we're going to scroll down, and there's a section on enabling channel layers. A channel layer, as it says here, it's kind of a communication system. It allows multiple consumers to talk to each other and to also talk to other parts of Django. And that's important if you're building something like a chat room. If we go back to the consumer file here, each individual client that wants to join the chat room, they'll get their own instance of this consumer. If we wanted to broadcast a message to all people in the chat room, we need to track which consumers belong to the chat room, and that's done using something called groups. But to do this, we need this channel layer to be enabled in Django Channels. This section here gives us a bit more information about this concept. A channel layer provides the following abstractions. It provides a channel, which is a mailbox where messages can be sent. Every channel has a name, and anyone who has the name of the channel can send a message to the channel. But there's also the concept of a group, and that's a bunch of related channels. And a group also has a name, and anyone who has the name of a group can add or remove channels to the group. But more importantly, they can send messages to all of the connected channels within the group. And that's how you would broadcast a WebSocket connection from server to a bunch of clients using this concept of a group. Now I hope that makes sense. I'm going to dive into all of this in more detail in a dedicated Django Channels course later on. But for now, let's go back to the application. If we scroll down here, what we now need to do is add a setting called channel_layers to our settings.py file. And you can see that for this channel layer, what's being used is Redis. Now we're not going to use Redis in this video, but there is an alternative if you're using channel layers. If you go to the channel layers section of the documentation, and if we go to the configuration section, you can see that as well as the Redis channel layer, you can also use an in-memory channel layer. Now the in-memory layer is good for development and for this video, but in production you would definitely want to use Redis. But what we're going to do is simply copy the setting here for channel layers. We're going to go to settings.py again, and at the bottom underneath the 𝗏𝗏𝗡 application, we're going to paste the configuration for the in-memory channel layer. And because it's in memory, it doesn't require any additional setup, so it's very easy to use in development. So once you've added that, you can save the settings file, and we're going to go back to consumers.py, and within the connect method we're going to find the name of the channel. So what we're going to do is print self.channel_name, and when you add channel layers, that basically is a property that is added to the class or the consumer. So let's add that and go back to the front end of our application and refresh this page. And if we do that and go back to the back end, you can see that we have this string here that's being printed. That's the name of the channel, and that is unique to this specific consumer. If we go back to the page and refresh, we're going to disconnect from that WebSocket connection, and we're going to reinstantiate the connection when the page reloads. We're going to go back to the server, and we can see that we get a different ID here. We get a different name. So the channel name is unique for each instance of a consumer. So every client that connects is going to have their own channel name. What we want to do is add that channel name to a group. And the group is an abstraction that allows us to connect multiple different consumers together so that we can then broadcast and receive messages from them. So the next step in this video is to create this group, and what we're going to do is add each channel that we get in the consumer from a new connection. We're going to add that to the group. Now if we go back to the documentation and we go back to the original page we were working through here, which was the tutorial part 2, what we're going to do is scroll down, and you can see that we have this code here in the connect method. That's used to join a new channel to a group when a connection is established. So what we're going to do is copy that, and we're going to paste it into our connect method. Now you can see that we are calling the self.channelLayer.group add function, and we are going to provide a name of a group, and we're going to provide the channel name to that function. Now we've already seen the channel name. We printed it out at the top. That's the unique name given to an instance of a consumer. What we need to do is define the name of the group that we're going to create here. So just above the async to sync function, I'm going to define a variable called group name, and I'm going to cache that on the class itself, and the group is going to be called user-notifications. And then we're going to pass this variable to the group add function. So let's change the code from the documentation here, and we're going to reference the group name. And the final thing we need to do is import the async to sync function. If we go back to the documentation, you can see that that's coming from the 𝗏𝗏𝗡 package. So basically what that does is it takes an asynchronous function such as the group add, and it allows it to be executed in a synchronous context. So we're going to bring that in here. Remember, the WebSocket consumer is a synchronous class. So let's go over the code in this connect method so that we understand what's happening here. We define a group called user notifications, and then what we're doing is we're using the self.channelLayer.group add function, and that allows us to add the channel name, which is unique, to the group that we have here, and it's called user notifications. So when we get the first connection from a WebSocket client to the server, it's going to add this channel to the group, and then another user comes in with a connection, and it's also going to add that user to the group as well. So for each WebSocket connection, we're adding it to this group, and then finally we call the self.accept method, and that accepts the connection. Now we need to do something similar on the disconnect method. Instead of group add, there's another function. If we go back to the documentation, you can see it's called group discard, and again we provide to that the name of the group and the name of the channel, and that will basically remove that channel from the group. So let's copy this code again, and we're going to paste that into our disconnect method, and again we'll change the name of the group to the name that we have cached on the class, self.groupName. So now we have a system where when a user connects, they're added to a group, and when they disconnect, when the WebSocket is terminated, they are removed from that group. Now the benefit of doing this is that we can now send a message to a group, and that will then be sent to all of the clients that are part of that group. So we can now broadcast a message to multiple people in our application, and we can trigger that from the server to the client. Now we want to send this notification to all users when we get a new user signing up to our application. So what we're going to do is use Django signals to find out when a user has signed up, and then when we get that sign up, we're going to send a message through the WebSocket to all of our clients to tell them the name of the user that has signed up. So let's now go to our core application, and we're going to create a signals.py file. And let's go to Django's documentation here. There's a page on signals. I'll link that in the description of this video. Signals allow you to perform actions when events happen in the Django ecosystem. And the event that we're interested in is here on the right hand side. It's the post save event. And this signal is called for a given model when the save function is finished. So let's go back to the signals.py file, and I'm going to bring a few imports in at the top. First of all, the settings module. We're also going to bring the post save signal in and the receiver method. And we're going to go down and we're going to use the receiver method as a decorator here. The first argument to that is the signal name, which is post save, and the second argument is the source, or rather the sender, and that's the model that is sending this signal when the save method has been finished, and that's going to be equal to the settings.auth user model. Now the auth user model is defined in the settings.py file, and this comes from the starter code. It refers to a core.user model, and if we go to models.py, you can see we have the user and it's inheriting from the abstract user, and this is our default user model in this application because of this setting that we've specified here. So within our signals file, this is the model that when it's finished saving, i.e. the post save signal, it's going to trigger this function that we're about to write. So let's call this function send notifications on sign up. And these notification functions take some arguments. We have the sender, the instance itself, that's the user model that has sent the signal, and we also have a boolean, and that's whether or not the user is created in the database or whether it's just being saved and updated. So let's now write the logic for this function. We're going to test if the user has been created, because we only want to inform and send notifications when a new user has signed up. We don't want to do it whenever they save and change any of their data. So if the user has been created, what we want to do here is trigger a notification to all of the consumers or the channels in our user notification group. So that's what we're going to try and do, but before we do that, let's go to the documentation for Django Channels. We're going to go to the channel layers section, and we're going to go to this bottom part here. It's called using outside of consumers, and this tells us how we can send to the channel layer from outside of a consumer class. We don't have access to the self.channel layer, but instead what we can do is use this get channel layer function. So we're going to copy this import at the top here, and we're going to bring it into our signals.py file. We'll paste that below the Django imports. So this is a function that we can call to get access to the channel layer. So let's create a variable here called channel layer, and we're going to set that equal to calling this function, and it will return the layer to us so we can use that to send notifications. Now the group that we want to send these notifications to is called user notifications, so we'll define a variable here called group name. And finally what we're going to do here is define an event, and that's going to be a dictionary of key value pairs. The first one is an important one. It's called the type, and the value of this key is going to be user underscore joined, and what that's actually going to do is it's going to call a function on our consumer that's called user joined. We're going to define that in a second and see exactly how that works. Let's go back to our event payload here, and we can define any key value pairs we want, but what I'm going to do is define a key called text, and that's going to be equal to the instance of the user who has signed up, and after they sign up they're going to have a username, so we're going to attach that as the text key in this dictionary. Now the final thing we need to do is underneath all that code we need to actually call the channel layer's group send method. Now like the two channel layer methods we see here called group add and group discard, we also need to wrap this in the async to sync function. So if we go back to the signals.py at the top, I'm going to import from asgiref that function, and then just below the code here in the signal, what we're going to do is define the async to sync function, and we're going to use the channel layer's group send method. And we need to pass to group send the name of the group that we're going to send the messages to, and we also need to define the payload, which is the event dictionary that we have above. Now like I said earlier, this type key in the event called user joined, that determines a function that's called, or a method that's called on the consumer class. So what we're going to need to do now is within the consumer we're going to call, or define rather, a function called user joined, and this is an instance method, so again it will take self as the first argument, and the second argument is the event that we're actually sending to this function. So that's basically the payload that we've attached here as the second parameter to group send. That's going to be this dictionary here. So we're able to extract the username from that dictionary. So let's go back to consumers.py, and what we want to do in the body of this function is call the WebSocket's send method. And that send method is going to send data to our client. In other words, all clients that are part of the group. And the text that we want to send is equal to the event dictionary's text key. And actually this should be text underscore data. And that's because the data we're sending over the WebSocket is text data. So let's save that. And what I'm going to do now is open two browsers and we're going to test this out. So we have these two browsers open here. As you can see, one of them is in incognito mode. What I'm going to do in the second browser is I'm going to go to the sign up page and we're going to try and sign up as a user. So I've filled in some details here, but on the first browser I'm going to go to the developer tools, and if we expand this out and go to the network tab here, we hope to see a WebSocket message appearing in this network tab, and it's been sent from Django to our client. So let's go back to the other browser and we're going to sign up, and we're not seeing anything appearing here, and that's because I've not actually registered the signal that we've created. What we need to do in order to do that is go to the apps.py file, and within the core config we define a function called ready, and that will take self as an argument. And within this application we need to register our signals simply by importing them into this ready function. So from the current application we import the signals module. If we save that and we try this again, hopefully it's going to work. On the left we have the page where the client is connected to our WebSocket on the back end, and on the right we're going to fill in some user details and sign up. So we have on the right a user called Dwight. If we click sign up and go to this notification WebSocket here, if we look at the messages, you can see that the username has been transmitted from our server to the front end, to the client. And that's been done through a WebSocket connection that's handled by Django Channels and is instantiated on the front end using the HTMX WebSocket plugin. Now the next step here is to actually return HTML content, because as you should know if you've watched any other videos, HTMX deals with HTML content and it swaps that into the DOM. So what we want to do is actually take this notification bar and we want to swap some content into that whenever a notification is fired to the front end. So let's go back to VS Code, and within our consumers.py file, this user joined method will send the username to the front end. Instead of sending that as text data, what we want to do is actually send HTML, which is then swapped in to our notification bar. So because we're returning HTML at the top, I'm going to import the getTemplate function from django.template.loader, and at the bottom we're going to remove this line of code and we're going to create a variable called HTML, and we're going to call that getTemplate function, and that takes as an argument the template that we want to get, and then we can call the .render function and pass a context to that template. So it's going to be a keyword argument of context, and we're going to create a username key here, and that's going to map to the event's text key. And remember that the event is coming from the signal, and the text key defines the username of the user who has just signed up to our application. So that's going to return the HTML for this particular template that we're going to create in just a second. And the only other thing we need to do in this function is called the self.send method to broadcast this to our users. And the text data in this case is going to be equal to that HTML from the getTemplate function. Now of course we need to create the notification.html template, so within the templates directory and the core directory we're going to create a new file called notification.html, and that will be in a partials directory. And the notification template is basically just going to be something similar to what we have on Tailwind Elements for the alerts page. I'm going to link this below the video, but you can get the code for these here. I'm going to paste a modified version into our template. So let's paste that in here, and what we're going to do is we're going to note a couple of attributes here. Firstly, we have a notification dropdown, that's the ID of the div wrapper, and that also has an attribute called hxSwap out of band, and that's set to after begin. Now what we're going to do is go back to the HTMX WebSocket documentation, and there's a section here called receiving messages from a WebSocket, and that's exactly what we're doing. We're sending HTML data that's going to be received on the client by this extension. And as it says here, content that is sent down from the WebSocket will be parsed as HTML and swapped in by the ID property. And it uses the same logic as out of band swap. So let's go back to the template. We have this ID called notification dropdown. If we go to the navbar that defines the notification section at the top of the page here, let's go back to navbar.html. We can search in this template for the ID that we're going to actually use here. It's called notification dropdown, and it belongs to this UL tag. And this UL tag defines the list elements that appear underneath this bell, this notification icon. So we want to perform an out of band swap that's going to put the content from the server into this bell, and it's going to do it after the start of the bell. If we go back to the notification template here, the HX swap out of band property is set to after begin. So what it's going to do is, for this bell here, it's going to find the UL containing all the list elements, and it's going to drop the new drop down after the beginning of this UL, so at the top of the list. I think it's easier to see this if we actually implement it, so let's do that now. If we go back to the template for our notification, the spans text says the username has joined, and remember we're attaching that username as context. So what we hope to see is that when a new user signs up, this content is then swapped into the DOM and it appears under this notification icon. So let's test that out. Again, we're going to go back to two browsers, and on the right hand side what we're going to do is we're going to log out of this application as the current user. I'm going to sign up as a new user. Now on the left, if you look at the bell here, you see that we have no notifications at the moment. If we go to the right hand side and sign up here, you can see that we get this notification appearing on the left hand side, and the WebSocket has sent that HTML from the server to the client, and the HTMX WebSocket plugin has accepted that and swapped it into the DOM, and it's done it after the beginning of this list, this UL tag. Now we can do this again. We can sign up another user, so I'm going to sign out with this guy and we're going to create a new user, and when we hit sign up again, we expect this notification to appear in the list, and it's going to be at the beginning, at the top of the list. So let's sign up with this new user Robert, and you can see we get the new notification. So that's the main part of this application. We are now connecting the front end and the back end with a WebSocket connection, and we're able to send messages from the server to the client, which then updates the UI when it receives these messages. So our WebSocket system is working, but we're going to perform a few extra tasks in this video. Firstly, anyone can see these notifications, including users that are not logged in. We only want to show these notifications to users that are actually signed into our application. So what we're going to do is go back to consumers.py, and we're going to add a few lines of code that are going to make sure that unauthenticated users do not see these notifications. Now at the top of the connect method, we can get the user who's sending this request, and we're going to cache that as self.user, and that's going to be equal to self.scope, which is a dictionary, and we can get the user key from that dictionary. Now self.scope is something that is available on the consumer class, and the user key gives us back the user who's sending the request. Now we can actually get this user key because if we go to asgi.py, we've added the auth middleware stack from Django Channels, and that adds this user key to the scope and allows us to fetch the user from the request. So we have access to the user now within the connect method, and we can write an if statement here, and we can check if the user is not authenticated. So it's going to be if not self.user.is authenticated. So if the user is not authenticated, what we're going to do is we're going to reject the connection. And on the consumer class, if you want to reject the connection, you can call the self.close method, and then we'll just return out of the function. So if the user is not authenticated, we're going to close the WebSocket connection, and we're not going to allow them to establish that connection. Otherwise, we'll just progress through this function as we did before. But we also need to add a bit of code to the disconnect method as well. Remember, in the disconnect method, we're calling the group discard method, and we're removing this channel name from the group. But we only need to do that if the user has been authenticated and has been added to the group. So what we're going to do is add another if statement here. We're going to check if the user is authenticated, in which case if they are authenticated, we know they were added to the group, and we can then call the group discard method. Now we need to do this because if you try and remove a channel from that group that doesn't exist, it will cause an error. So by doing this, we're checking to see whether the user is in the group in the first place, and then we can remove them when they disconnect. So that's some additional code on the back end on Django that will stop unauthenticated users accessing the WebSocket connection. What we're now going to do is go to the client side again, and what we're going to do is write code to check these notifications and display the number of notifications in this bell. Now to see this in action, let's go to the navbar.html, and I've left a comment somewhere here, which is this one here. It's the number of notifications box, and this is a span tag. And if we scroll into the text content, and let's say we put the number 5 there, if we run the server and refresh this page, we should see the number 5 appears at this bell here, so we can then get some visual feedback on how many notifications we have. Now what we're going to do is actually make this dynamic, but we need to write JavaScript code to do that. So let's go back to our template here, and we're going to remove the number 5 from that HTML, and we're going to go back to the base.html, and at the bottom we're going to write a script tag tag here, and within this script tag we're going to grab the span that contains the number. It's got an ID of notification number, so let's go back to our script and we're going to write a variable called number span. That's going to be equal to document.getElementById. And to that we're going to pass the ID of the span, which is notification number. So now we have access to that element. Now what we need to do here is increment the number in that by 1 every time we get back a WebSocket message telling us a new user has been added. So what we're going to do here is in the document we're going to go to the body element, which, remember, if you scroll up, contains our HTMX WebSocket connection, and to that we're going to add an event listener, and we're going to listen for an event that's defined by HTMX's WebSocket client. So let's get back to their documentation now. If we scroll down, you can see there's an events section here. I'll link this below the video. Now one of the events is this one here, HTMX WS after message, and this event is triggered when a message has been completely processed by HTMX, and that's what we want to actually listen for in our document body. And then when we get that message, we can perform the action of updating the notification number. So let's go back to VS Code, and the event listener is going to take that particular event from the HTMX WebSocket plugin, and when we get the event, what we're going to do is call this callback function, and we're going to create a variable here called number of notifications, and that's going to be equal to the number span that we got on line 36 above here. We're going to get the inner HTML for that particular element, and that's going to either give us a number if we have a number there, or it's going to give us nothing if we haven't got anything. And remember, by default, if we go back to the navbar.html, that span does not contain anything by default. So when we first do this, it's not going to have a number, and this particular line of code here is going to give us nothing. So in the case that it gives us nothing, we're going to write an if statement, and we're going to say if the number of notifications is null. In that case, we know that we're dealing with the first notification, so we're going to set numberspan.innerHTML, and we're going to set that equal to 1. Now in the case that we have a number already in there, in other words it's not null, we're going to write an else block here, and we're going to say numberspan.innerHTML, and that's going to be equal to the number of notifications, but we need to parse that as an integer. So we'll call the parseInt function and we'll pass number of notifications, and then we can add 1 to that. So let's test this out now. If we go back to our page here and we refresh this page, and I'm going to add another browser here. So let's say we have a user on the left who is signed into the application, and we have another user trying to sign up on the right. When we hit the sign up button, you can see we now get this notification that tells us how many notifications there are, and it also gives us the content of that notification. If we then go back to the page here and try and sign up with another user, and let's call this user Steve, when we hit sign up we get the notification, but actually the element is not updating with the number 2. So let's inspect the console here and we'll try and figure out what's gone wrong. We've got a reference error, number is not defined. So let's get back to our code here, and this is my mistake. Obviously I've not called that the right variable. It should be number span, and that refers to the span that's going to show the number, and in the else block that was incorrect, so that did not fire correctly. Let's try this again. If we sign up with one user, we get the notification saying 1. If we then try and sign up with another, when we submit the second form, you can see that it now updates and it has 2 in there, and this will keep updating if we add new notifications. So we now have visual feedback as to the number of notifications that we have. The final thing to do in this long video is to implement the clear all button. When we hit this, we want to clear all of the notifications and remove the number from the icon. So let's go back to our base.html, and we're going to work on that in this script tag as well. And again, if we go back to the navbar, at the bottom we have this button here, it's an anchor tag, and it says clear all. It has an ID of clear button, so we're going to copy that. And once we've copied that, we go back to the base.html, and again at the top here I'm going to get a reference to that button, and we'll call it clear button. It's going to be document.getElementById, and we'll pass the ID to that function. Once we've got the element by its ID, what we're going to do is add an event listener to that element, and the event that we're listening for is the click event, and when we receive that we will fire a callback function, and what we need to do here is remove all of the notifications and also remove the number. So let's go back to our navbar.html, and what we have here, if we search for that notification dropdown, remember that's the UL tag that contains all of the list elements for each notification. Now what we need to do is remove all of those except from the list element that contains the clear all button. So to do that, what we're going to do is go back to our partial that's returned by HTMX, and that returns a div. So what we need to do is get all of the div tags that live underneath this UL element, and we can remove them from the DOM. So let's go to base.html. Within the event listener, we're going to get a reference to the notification dropdown by calling getElementById. So that's the dropdown. Then we need to get all of the divs that live within that dropdown. So let's call this variable notifications, and it's going to be equal to dropdown, and we'll call the query selector all method to get all of the divs underneath that. This gives us back all of these notifications that you can see in the UI. So for example, Harry2 and Harry here, these are both notifications. They're div tags that live underneath the UL tag. So what we now need to do is remove them from the DOM. So what we're going to do is call the notifications.forEach function, and we can pass for each notification a callback function, and all we need to do for that callback function is call the notifications remove method. And this is just a method in the document object model that will remove an element from the DOM. Once we've done that, we are basically done with the notifications. We only need to also update this number here. If we remove the notifications, we don't want to see the number. It should then be removed from that span. So let's get back to our JavaScript, and this is the last thing we're going to do. And it's this number span here that shows the number. So we're going to copy the name of that variable, and we can set the inner HTML in that span to an empty string, and that's all we need to do here. So let's test this out and refresh the page. Again, we're going to sign up with this user here, and we see the notification on the left, and then I'm going to sign up with another user. And when we sign up with that user, we now have two notifications, and you see both of the users. What we want to do now is clear these by hitting this button. If we do that, you can see that the notification bell has no longer got the number, and we also don't have the notifications listed here. So that has worked successfully, and if we sign up with another user, when we hit sign up, that whole system is still working. So we're able to get notifications from the server, display them on the page with the HTMX WebSocket extension, and we're also able to clear these notifications from our page with this clear all button. So this is quite a dynamic system. It's been built up using Django and Django Channels on the back end, and using HTML and HTMX on the front end, and we're interfacing with a WebSocket, and the back end is sending the front end these messages, and HTMX is doing what it does best on the front end. It's swapping that content into the DOM, and we get the appearance of a dynamic page that's updating based on these server generated notifications. So this has been a long video. Thank you very much for watching. I hope you've learned something from the video. If you've enjoyed it, please like and subscribe to the channel. If you're interested in more content on Django channels in the future, please let me know as well, and we'll see you in the next video.